Sorry for the
And
background
we're
noise.
go. Good morning, everyone. Our apologies for some minutes of delay. As usual with these online events, we were having some technical problems, but hopefully all solved for now. So thank you for joining us in this second day of our webinar series. My name is Renata Barros, and I'll be your host today. I work at the Geological Survey of Belgium, and I'm the coordinator of GeoConnect³d, the project that is organizing these events for you this week. And today we will explore the theme of framing groundwater resource management. We have 2 more webinars coming up, tomorrow and Friday, both from 9:30 a.m. Brussels time. And you can still register on each event page, and the link will be copied in the chat for you as well. And this is today's menu. We have 2 very, very interesting talks to look forward to before a Q&A and interactive sessions. So for now, I would just quickly introduce our great group of today, starting with our guest speaker, Koen Burten. I don't know if I said that correctly. Sorry. He's a researcher and project leader at the Belgian Nuclear Research Center. Hello, Koen.
Hello.
Thank you for joining us today. And our project speaker, Chris Piesens. He's a researcher at the Geological Survey of Belgium. Hi, Chris.
Good morning, everyone.
And our moderator, André Bocin-Dumitriu from the Geological Survey of the Netherlands. Hi, André.
Hi, good morning, everybody.
Yeah, it's great to have you here today. And and to have you watching us as well. You see that this bit of introduction, if you watched us yesterday, will be a bit of a repetition, but I would like to explain a bit or give a bit of background on the GeoConnect³ project before explaining how today will work and moving on to our presentations. So you know that this will be brief. Sorry. So our project is part of the GeoEra research program funded through a Horizon 2020 Research and Innovation grant. And we, as involved in geoscience, we know that we're strongly dependent on resources coming from the ground below our feet, the famous subsurface. And groundwater, for example, is one of these essential resources for our existence. And GeoEra has the main objective to contribute to the optimal use and management of the European subsurface. And these uses of the subsurface, they're covered by 3 research themes: geoenergy, groundwater, and raw materials. And a 4th theme is the information platform, which is the common objective of all of the other projects, to make the data available online for free visualization and download. So GeoConnect³ is part of the geoenergy theme, along with other projects covering different aspects of geoenergy resources. For example, geothermal energy, inventory of European faults, 3D modeling of the subsurface, and so on. But GeoConnect³, as the name suggests, is a point of connection between all of these projects in the geoenergy theme, and also others in the groundwater and raw materials themes as well. And today, for example, we will see a nice link with Voguera, the GeoEra project investigating vulnerability of shallow groundwater resources to deep subsurface energy-related activities. So the goal of GeoConnect³ is to provide a robust model that can accommodate all types of geological information generated across these different topics. And I will explain a bit more about this in a second. But first, what is the motivation behind it? So the idea of our project came from the perception that we'll be using more and more resources coming from the subsurface because we're going to go through deep changes over the next decades to achieve climate neutrality goals. So sourcing affordable and clean energy, increasing sustainability, climate action, and specifically relevant for today, access to clean water. A lot of these goals for a better future, they rely on different uses of the subsurface. And the subsurface is ruled, of course, by geology. So geological information will become more and more crucial for good decision making. However, we think science and policy are not as close together as they should be. On one side, geological information exists and our knowledge about the subsurface is constantly improving. But is this information accessible and understandable? On the other side, guidelines and decisions about the uses of the subsurface, they are already being made and decisions will only get tougher in the future. So is the scientific information out there being used to its full potential? We think the answer to both these questions is no, and we want to help close that gap. And to achieve this, we are 20 partners from 16 different countries, and we have 2 cross-border case areas, the Ruhr to Rhine and Pannonian Basin, and 2 one-country pilots, one in Germany, one in Ireland. And just a note that this webinar series has some focus on the Ruhr to Rhine area, but that you can expect a similar event for the Pannonian Basin area later this year. But anyway, we share a single goal to develop and test a new methodology to prepare geological information related to the subsurface in a more understandable way and make them easily available for stakeholders on GeoEra's online platform. And we hope this will help to bridge the gap between science and policy, especially in subsurface management. But what is this new methodology that we keep talking about? So GeoConnect³ is rethinking the way to present geological information. And we're doing this by using information available in conventional geological maps, 3D models, and so on, but digesting this information to make it more intuitive by looking at geological features in terms of their boundaries or what we call limits. We're also incorporating information that is usually overlooked, but that point to specific geologic manifestations. So the combination of these 2 types of information results in our structural framework model annotated with geomanifestation data. And like this, we hope to improve geological understanding of any area. And our project started in June 2018 and will end June next year. The first version of the methodology got ready 1 year after the project started. And now it's time to test this methodology. And part of this is to get the feedback from potential end users. So you that are watching us today. And this is what motivated us to organize these online events this week. And as I mentioned, there will be another event like that organized by the Pannonian Basin in a few months. And we will have a final joint event for stakeholders early next year in January. So what to expect of today? We will start with the presentation from our guest speaker, Koen, on groundwater. And we will follow with a GeoConnect³ presentation by Chris, demonstrating how we can provide context to groundwater data. We will then have a Q&A session with our two speakers and end with an interactive session using polls to get the feedback from you about what you've seen. So during their presentations, please write your questions using the Q&A button. It's located at the bottom of your screen. And you will see that you can upvote questions using the little thumbs up, so we know if many people have the same question. And to get you prepared for the interactive session later, I will do a test right now. And we will use Poll Everywhere. And it's very simple to join. So you go to pollev.com/ggeoera900. The link should be available for you in the chat. So you register with your name and you get ready to answer our test questions. If you've done this yesterday, I encourage you to do it again, because we will have this data all compiled per day. So it would be nice to have your input again as well. But test questions will be the same. So I'll go ahead and open the first one that you should be seeing right now. So the first question is, what is your background? And if you have a background in geoscience, please specify the area. If it's geochemistry, hydrogeology, or something like that. So we get a few answers coming in. Science communication, hydrogeology, geophysics. So we expect a lot of people working with hydrogeology today. All right, that's good. Hydrogeology seems to be the most common. So that seems to work well. I'm going to go to the second test question now. Where are you based? Please click on the map. And if you're not in Europe, you have this smaller map on the top right that you can use. So I see some pins popping up. That's nice. We have a lot of people in the Rooterine area, which is good. Okay, that seems to work well. So you're ready to go for later on. And so without further ado, it's time to kick off our presentations. So we will start with Koen Beerden from the Belgian Belgian Nuclear Research Center. Just now give me a second. So I get Koen's presentation set up. So Koen, I'm giving you remote access to control the presentation. Should take a few seconds. But Koen will start by telling us about groundwater at the receiving end, taking into account deep subsurface activities. So yeah, I see it's moving already, so you should be ready to go.
Unmute. Okay, good morning, everyone. Welcome to this session, also from my side. So I will basically, in this 15 minutes, we'll try to guide you through the basics of the Voghera project. In the end, I will also show some recent results we obtained on one of the pilot sites in this project. So the aim of the Voghera project is to improve the scientific understanding of the vulnerability of shallow groundwater to deep subsurface industrial energy-related activities. To do so, we will try to develop a consistent approach to assessing a range of subsurface energy activities. And now it comes, of course. So these subsurface activities, they include conventional oil and gas, geothermal energy, also unconventional oil and gas, storage of energy, gas, and also waste disposal. So this is a GeoEra project, which means we are in the project with a number of partners and pilot sites. So these are the countries that are involved, and the corresponding pilot sites are indicated. It is, in terms of budget, a rather small project. I think it's even one of the, it's the smallest GeoEra project so far, I think, if I'm well informed. Nevertheless, we try to do our best to do a good job, of course. Yeah, the approach, I know, apologize for a lot of text in the first slides, but gradually you will see the more and more figures will pop up. So the approach is, well, first, the basic idea is to develop conceptual models of the subsurface activities and to indicate possible pathways of contamination to groundwater. This will become much more clear in the next slides with some diagrams. And then the second point is that we will then try to use evidence to assess possible pathways. Pathways could include, for instance, fault zones or abandoned wells. To assess possible pathways at such pilot locations using stable isotopes or dating or residence time indicators, temperature profiles also, but also more conventional state variables such as hydraulic heads. As you will see later in this presentation, what I will show you, that we also use, of course, groundwater flow data and 3D geological models. And in the next phase, the idea then is to develop a framework for assessing the vulnerability. And the framework should be all-inclusive. It should be a generic framework that can be applied across a range of European hydrogeological settings. And that can also then be used as a tool for regulators and decision makers. And then in the final phase, the vulnerability framework will be tested at pilot sites to see if it actually works. Yeah, these are the expected outcomes. Of course, the overall idea is to get an improved understanding of groundwater vulnerability to a range of energy-related activities. And hopefully this then will lead to improved subsurface spatial planning and decision-making. Okay, let's move on to the pilot site. So as you may have seen in one of the previous slides, there are 4 pilot sites. One in Hungary in the Pannonian Basin, one in the UK, the Vale of Pickering, and then 2 pilot sites are located in the Ruhr Valley Graben. What I show here is a figure from another GeoEra project, the resource project, namely Work Package 3, H3O+, which aims at mapping, assessing groundwater resources in the Ruhr Valley Graben. So I think it would be interesting to show the 2 pilots that are located in this setting. The Ruhr Valley Graben, yes, it's a subsiding area. It's it contains hundreds of meters of neogene, mainly neogene sediment, and also earlier rocks, of course. So it is an interesting place for their ideas to develop certain subsurface activities such as geothermy, also waste disposal, and storage of energy and gas. So it's a possible target for these subsurface activities. Now, we're not only looking just at the Ruhr Valley Graben, but we're actually looking at Ruhr Valley Graben faults. And why would that be? Well, faults, they can play an important hydraulic role in flow and transport. Faults can either be, and that's what I want to show here to the right. It's a figure from a publication by Bense et al. In Earth Science Reviews. Faults can be hydraulic barrier, horizontal hydraulic barrier, or either a hydraulic conduit. So in upward or downward direction, it can be a hydraulic conduit. Nevertheless, it can also be a hydraulic barrier. So the role of such faults in vulnerability of shallow groundwater to deep subsurface activities is crucial to understand. So one pilot site is the Pale Boundary Fault near Vegel in the Netherlands. It is a normal fault located in the northeastern edge of the Ruhr Valley Graben. It has a deep signature down to thousands of meters, also a shallow signature with offset Neogene Pliocene sediments up to 100 meters. Currently, at that pilot site, there are no deep subsurface activities, though there is one abandoned hydrocarbon exploration well, which makes it an interesting case. And there is drinking water abstraction activity, of course, as well there. It's the blue area indicated here. I just show this as an example because the real case that I will present today is about the Raw Fault near Mol. The Raw Fault is located at the other side of the Ruhr Valley Graben. It's one of the westernmost faults. It's a dormant fault, which had been active in the Middle Pleistocene at the latest. The Raw Fault near Mol, well, deep subsurface activities, the only deep subsurface activity there is right now is there is one geothermal well in the vicinity here. There are other planned activities as there is waste disposal. And of course, there is a lot of drinking water abstraction in the area. Here you see in the geological cross section here at the lower left lower screen is a cross section of part of the study area. You can clearly see the geological expression as the Raw Fault as a normal fault with an offset of up to 100 meters of, for instance, boom clay. That's the light blue layer here. It's boom clay. It has been offset indeed by the Raw Fault and other layers as well. What is also indicated here in this figure is the general water flow direction in the aquifers. So this is the catchment boundary here, the vertical line on top of the figure. And we see the general flow pattern here, indeed, from east to west. Okay, so in one of the first slides, I told you about this generic conceptual model that we would develop. Well, this is it. This is what we came up with, which this diagram is supposed to cover any setting in Europe. I know it's ambitious and it's probably not completely inclusive, but we nevertheless try to do our best to include many of the geological settings. And of course, because we're talking about pathways and receptors, and these are included in this diagram. What we will be, our setting in the Raw Fault, what we will be looking at today is mainly these fresh aquifers, which are separated by impermeable sediment in the more shallow domain of the generic geological setting. So we will basically be looking at this part. We look at shallow aquifers, some impermeable material in between, and normal faults. That is the domain we will be looking at. As you see, there are many others indicated here, and we can talk about it later on, or you can have a look again at this figure. It's, by the way, this is from a published deliverable from the Voghera project. So I guess these diagrams are freely accessible now. Well, yeah, what are the potential pathways for geothermal energy? I'm only going to talk about two. One possibility could be that through injection of liquid comes into existence, and moving material along, for instance, a normal fault up to the more shallow domain, and in such a way that it may reach an aquifer. And another traditional case, I show these two because these are one of the two potential deep subsurface activities in the Ruhr Valley Graben. In other pilots, there are other activities, but okay, because we focus on the Ruhr Valley Graben, I only show these. For energy and gas, it's basically the same. There is also the possibility of leaking and also transport along permeable faults from a deep repository. There might be a pathway, contaminant pathway up to the surface along faults, for instance. So our first assessment of the impact of the raw fault on the local and regional hydrogeology is done using, while employing a model, that's the Neogene Aquifer model. The location of the Neogene Aquifer model in Belgium is indicated here. This is a more detailed view of the NAM model, as it is called. So it coincides with the Nete Basin. Here you see the shallow geology, mainly Neogene sediments. And the raw fault is indicated here. It's one of these fault lines here. There are other fault lines, but we will focus on the raw fault here. Now, this is an old view of the our NAM model. Meantime, it has been updated by Alberto Casillas, is our PhD student. He's working on this topic here. So he made a lot of effort to update this model using the new geological information that became available in the recent past with all these cross-border projects. And he also improved the fault traces, the exact location of the faults according to all these new insights that became available. Okay, now let's have a look at the detailed results. So what you see here is the simulated heads in the NAM model without imposing a horizontal flow boundary to the raw fault. So this is the raw fault. And it has been, in this exercise, it has been assigned no flow boundary properties, so to say. Now, what you see is that, and that's the dots, the color in the color dots, they indicate the value, the magnitude of the residual. The residual observation is actually the modeled groundwater head minus the measured. And what we see is there are some areas, okay, there is some scatter, but there are some areas there where the, and can I go back now? Where the modeled, oh, thank you, where the modeled groundwater head is clearly below the measured one. That's here. Now, if we do that exercise again and we impose a horizontal flow boundary to the raw fault, we see a completely different picture. And we see indeed that the simulated optimized head then increases in comparison to the model had when no horizontal flow boundary is imposed to the row fault. This is a very nice result, and it basically confirms what we suspected, that the row fault, indeed, as in a sedimentary basin, these normal faults, they often act as a hydraulic barrier in a horizontal flow. What Alberto also did, he did using that model some the particle tracking. This is a forward particle tracking exercise. What is shown here is again a west-east cross-section through the Nete basin, through that NAM model. The different layers here are indicated in different colors. This is the model bottom here. Bottom boundary is the boom clay, and here we have the different neogene hydrogeological units. The row fault here is indicated by the vertical arrow. You see, there are other faults, but the row fault is clearly the most prominent one here. And what this particle tracking exercise shows very clearly is that there seems to be an upward flow caused by the row fault. So in the upstream direction, there seems to be upward flow in front of the row fault. Now, the most interesting thing here also is that it's only the case with the row fault. So the other faults, although they were at a certain point also parameterized with horizontal flow boundary properties, they did not seem to be very sensitive. Well, okay, so that was the last slide. To summarize then, we can confirm now that the row fault above boom clay is a horizontal flow boundary, hydraulic barrier. This is, as I indicated, in accordance with previous observations along the Ruhr Valley Graben. However, this still needs to be confirmed by a transport model using observations of helium-4 concentrations and also radiocarbon. What we still need to assess or investigate is whether the fault also acts as a vertical conduit. It is known, as I also indicated in one of the previous slides, these normal faults in such settings, they may, even though being a horizontal hydraulic barrier, they may act as a vertical conduit. And then finally, okay, so in one of the last months of the project, I guess the vulnerability assessment tool is to be tested also at this pilot site. Okay, so that was my last slide. Then I thank you for your attention.
Thank you very much, Koen. That was a very nice talk. And the conceptual model diagrams from Voguera, they are really nice.
Thank you.
So for who's watching us, on GeoEra's website, you have each individual project's pages. So you can find this material from Voguera on the GeoEra website as well. So that was very nice. And don't forget to write your questions to Koen using our Q&A. And now we will follow up with Chris, who will be talking about the deep and the drinkable, linking and understanding the subsurface worlds. So Chris, I see you're already sharing, so you're ready to go.
Perfect. Then I'll start talking right away. So yeah, thanks, of course, to our guest speaker. It's always, we like to have that link, especially here with a speaker from the Voguera project. And I'm going to not show a lot of new things, certainly not about the hydrogeology part. We're not a hydrogeology project, but largely about how we look at these results and how we think we integrate them in order to get a better and more general view of that. And obviously that's on the other side. Vogera is working. We are working actually on the deeper and much more geoenergy related aspects. And well, there's a bit of controversy between those two disciplines. And I shouldn't exaggerate it, but if I do, I get a nicer story. So I'm gonna do it anyway. Drinkable, everybody likes water. I mean, there is nothing wrong with water. That's just a very positive thing. On the other side, if you develop anything other in the subsurface, there's always some kind of nasty or controversial aspect there. So we're going to come back to that, but really towards the end of the presentation. We'll just focus first on getting things together. A very quick slide, just showing how we're going to different sessions now. Yesterday we were working on geotourism, which is a topic we don't necessarily do in our project. We like it, but it's not in our proposal. Geothermal is what we're going to do tomorrow. That's a very focused on geoenergy related theme, which we deal with quite seriously within our project. And today we're doing groundwater, but all of these aspects come together. We see ourselves very much as a cross-thematic project. So we're gradually moving to our own core expertise, but we actually are very open and very welcome to seeing how what we do actually aligns with other projects. And Vogera is a perfect example because they do that from the opposite side. They look at how groundwater is vulnerable to deep subsurface activities. So there's a perfect match there. Renata already mentioned a little bit about the methodology that we are working with. I'm gonna quickly talk you through a couple of the slides. Those that were present in yesterday's sessions will see this as a starting shot, which looks very similar, but don't worry, I'm only going to repeat the things that are really crucial and important. And the story itself is always a little bit different. So here we look at the map of Europe. There's no geology on that, but obviously as geologists, we like to see that arriving there. And you will see what I'm doing now is something that you will see the repetitive steps. We first put in limits or the boundaries to things, and then we start coloring them. And these are the obvious ones. These are the active plate tectonic boundaries, or the current ones. If you color if you define these to use these to define the area and the volumes in between, you get your active plates. Now, when it comes to active plates, Europe is not a very interesting place to be because it's just one big plate. But if you start adding to that the past plates, which have now come together, collided in the past, then you get see much more variety inside, and you can add things like boundaries between oceanic and continental crust, or the big faults that cross Europe. And now suddenly Europe is already full, and we've just put 3 different types of boundaries on there. You can immediately clear up that picture by starting to color in between the lines again. So if you take the blue lines, the basic plate tectonic boundaries, you get these really the structural building blocks of Europe, which we give fancy names. That in itself is not yet hydrogeology, or it's not easy to relate to that. But it's interesting to know where you are and on what kind of microcontinent you're standing. You will also see, if you look closer now, we've hatched the different origins that have generated during this geological history. But when we talk about groundwater, and especially in relation to other uses and potential conflicts, you want to look at basins. There are different kinds of basins that you can define. The ones that we're going to look at, because we're very close to one. When we're going to zoom in on what Vogera, the case study of Vogera, are the grabens. And the grabens is what you see here colored now in gray. You see them a little bit all across Europe. They have got very different histories, but basically what you see, when you can recognize them by identifying the normal faults and then seeing what the areas of subsidence in between. This is just the graphical view. It's very easy to go through this, all of these aspects very quickly. There's also, we also think of it in terms of concepts, and it's not immediately evident from this. So I'm just going to give you one example here. We're talking about grabens. I'm showing you here the concept of a half graben, and basically you could do it also for sedimentary, simply sedimentary basins with an unconformity. And you see here the half graben has one fault boundary here, and the other one is an unconformity. With a traditional, or the grabens that we're looking at now, the more symmetrical ones, you will have at least two faults on either side, and possibly also an unconformity in between. Just to give you an idea of the concepts behind how we are building these, what we call the structural frameworks of Europe. So there's a lot of hidden information behind the simple lines that we're drawing. Now, if we start again from the European view that we constructed, we also add a lot of information in the different zoom levels in zooming in. So we're zooming into the area now. And this is at this scale of detail, the amount of information that we have in for the area that we're looking at. And the most important structure for this presentation is this one here, the Ruhr Valley Graben that you see there nicely bounded in red. And we're going to be exactly on the margin of that Ruhr Valley Graben, actually. And for those that know, well, this is Belgium. There's no scale here, but this is Belgium. You've got the Netherlands here, the North Sea, and you can just see a little part of the UK popping up across the North Sea. Since we're looking at not only talk about groundwater, but also about other activities, we also put the things that are currently in our database. Obviously, we're just, well, we've passed halfway of our project, but we're still building up this, both making it visually more attractive and also adding more layers of information. And I was saying we are a cross-thematic project. So what you see here, these black dots are actually the lead zinc mineralizations that come from one of the other GeoEra projects, have been borrowed from them, and they're perfectly compatible with what we are doing. And we plotted them on there because if we talk about groundwater here, how quickly and how far are other potential activities that we see? Well, this distance is quite large. It's certainly over 100 kilometers, but it's good to be aware of what different things are around there, and we'll see some more activities later on. But first we'll zoom further in, and you see now that the simplified faults of mainly the Ruhr Valley Graben split up and become much more complex set of faults at this scale level. So it's good that we still have in the background this dark gray that represents the Ruhr Valley Graben. And you already see, for those that know, but we'll be highlighting in later slides, the Rau faults popping up here. But before we actually look at the actual Voghera results, linking them to our framework, just to give you an idea of how busy the subsurface can get, this inset here shows, in especially the highlighted colors here, from another study that we did previously, how likely or how suited the different deeper reservoirs in this area would be for storing CO2 as a part of CCS projects, for example. We're not yet doing this, but this shows very clearly how many different reservoirs are stacked here in this relatively small area here in the deeper subsurface. It's not only reservoirs cannot only be used for that. There are other activities that have been going on in the past, such as coal mines, especially in the eastern part of what's, well, this basically the Campine Basin here that we're looking at, which are still there. I mean, the infrastructure is there. The mines have ceased, but they start from 400 meters and reach to depths of over 1,000 meters. You've got deep geothermal projects in the past already, and now 2 new ones are being developed. Seasonal storage of natural gas is happening in this area, and actually are only natural gas storage location in Belgium. And as Koen mentioned, there are also plans or research going on for potentially using this for waste disposal. So a lot of possible activities going on here. So whenever you look at one activity, you should be very much aware of that context. And that's quite typical for basins. If you have a nice basin, it will attract a lot of potential activities towards the future. So central question here is really how much can you develop in one basin? I mean, you've got a long list. Will you just pick one activity from that? That's a question that we're not going to solve today, but we'll certainly touch upon it on Friday. But in order to explore that question, the general approach, and I'm now using deliberately some of the pictures again from Koen's presentation. You will start with geological model. You will then do some reservoir exploration there, or reservoir modeling on that, and see how well that matches up with the observation that you make. And where the observation are a little bit off or anomalous, that's what we call geomanifestations in our project. Basically, it's a term that we use to refer to indications that or manifestations that point to processes in subsurface or structures in subsurface that specifically trigger these things. And by understanding these, by being able to correctly model them, you are able to improve your knowledge and your understanding of the subsurface. You see a lot of parallels here with what Koen has been telling you. I'm basically redoing his story, but inside our framework or way of thinking that we developed in our project. And I can go very quickly over this because basically Koen emphasizes a lot already. Faults indeed can be conduits of barriers, and it's very nice that from basically that concept, that understanding, they just went on to pick out one of these faults and went into detail there to see if actually they could determine based on their measurements what was going on there. And obviously graben setting, if faults can play those roles, you have to be very much aware of that in graben settings because they're fundamentally and by definition your faults go really deep. And okay, next step is now to actually start linking or introducing Voghera results into our framework. And that's what you see here on the background. You see their geological model, and Koen already said, yeah, it's a little bit outdated, but that doesn't really matter. And I will really be very, we hope that ours is a little bit more up to date now, and probably as up to date as their most recent version now. If you would zoom into this, we're not going to do this because it's getting a little bit technical. You would see some differences between some of the faults, some faults that are there in our model, not in theirs, or some differences in traces. But we have a way of identifying structures with each other in order to be able to introduce them and actually know what we're talking about. Also defining how well the model, in this case, the base for a groundwater model, fits with the frame that we've developed for this area. And in this case, it works pretty nice. And you see, just identifying here, because there are quite a lot of faults here, this is the raw fault that we're talking about. And again, the trace is not identical, but it's close enough for the two to actually look at the results and introduce the results directly into each other. And here in the background, this is their first modeling run, where they said, yeah, the fault is no hydrogeological barrier, so doesn't prevent flow in a horizontal direction. And once they corrected that for that, and they said, no, it has some specific properties that prevent or to some degree horizontal flow, you come up with this anomaly, and that we can actually see here. And basically, this is how we could link from here, from this easy way of linking, we could actually start exploring much more what this means and how the different, how to bring groundwater together with other uses of the subsurface and see how things match up and what we can learn from each other. So here there's no conflict. Everything matches up perfectly. Rauwvolt is a very nice delineation as an important fault delineation of the graben, but also clearly has a hydrogeological meaning. And that is all that information, all that very detailed information is very important to develop actual activities, but it is important to know where these details sit in the larger pictures. And that's just what we want to show here. And also how quickly you can move through all these different levels of information with what we call the Google Map or Google Earth kind of experience. You zoom in and zoom out into the into details in just a blink of an eye, because details, I mean, it's a very wrong word actually to talk about these details. The details actually determine how well we understand the basin and what we can actually do with them, which kind of activities we can develop in there. So indeed, row fault is important for both projects. Very nice match there, very nice case study. Yeah, it like Koen already said, yeah, that's what they're currently working on, I guess. Row fault is one fault and a very important one in both our views, but there are several parallel faults, and which at least hydrogeologically work differently. And that's an observation for the moment. It would be nicer if we can actually come to some level of understanding where we can understand why there is a difference between these two. And maybe Voghera will do that at some point, but right now I'm not presenting their results. This is their job. If they come up with something like that, we will be happy to look at that in our setting as well. And then, as I already said, anomalies are very important. These are the things that actually form the perfect test to say how well you understand an area. And just glancing over them is something as a research, well, it's something that researchers do not do. It is really a test of your knowledge. And just to illustrate that, by Voghera clearly showed that by saying, oh wait, there's something wrong here in this model along this fault. By looking into that, you come to define a horizontal barrier, and as a result of that, you actually come to vertical flow paths that they are investigating now further, because these ones that actually can become important in discussing which kind of activities you can stack on top of each other in the subsurface. And as I already said, I'm not introducing anything or presenting anything new here. I'm just redoing the story of Koen to show how it actually aligns very well with what we are doing and our approach, and how easy it is. It then becomes to combine results from basically projects that are developing just along each other without having any direct connection or continuous connection with each other. And then very quickly, this is I promised to end here with groundwater being the very nice one, being important for us, for nature, and being very threatened, and also by the deeper activities. And this is a little bit the controversy between these two. I'm on the red side here, just to be clear, and Koen is on the blue side and the safe side. Voghera obviously has been talking a lot about their groundwater being a potential receptor or being threatened by these other deep activities. We will on Friday have a little bit a more balanced view, hopefully, on this, because obviously on both sides are you need to balance the value of the activities on both sides and also the risk in order when you start talking about full-scale subsurface management. Okay, and Renata, I'd like to stop here, and then I give the screen back to you.
All right, Chris, thank you very much. Nice overview of the structural framework and how things can be included in it. Finishing with some interesting analogies for sure. But please write your questions to Chris in the Q&A section. But I see that we already have some good questions there. So now I will hand over to Andre, who will moderate our Q&A.
Yeah, thank you, Renata, and then thank you, Chris and Koen. Yeah, we got really interesting questions. I think we already, Alberto has to defend his PhD through Koen by the questions that we received, because some of them, they are quite technical, which is good. I'm perfectly agreeing with it, but I would need probably Koen answers and then Chris' wisdom to reply to them. So I will start with the one that caught the most attention and was voted by the most. So it comes from Simon 6. So he basically put two questions. Can the hydraulic properties along the fault change along the fault? It seems from the model that only the northern part gives higher heads along the fault. So can you comment on that, Koen?
Okay. Hello, Simon. Yes, that's true. The expression is much more clear towards the north. That's true. Yeah. I think what you came up with here is a possibility that the properties are not homogeneously distributed over the fault. That's a possibility. And yeah, that's my only guess right now. We have to look into that in more detail probably, and perhaps Alberto, if he would, I don't know if he's joining us, but perhaps he has a much clearer view on that. But well, in any case, it's what I appreciate, Simon, is that indeed the observation is made, and we're definitely going to look into that.
Yeah, thank you very much, Koen. As I said, it's a difficult task to defend Alberto's PhD online ahead the schedule. But of course, one thing that we propose, and I think we spoke with Renata and Chris, having the experience of yesterday webinar, that we're going to try to reply to all the questions that were put today afterwards. But definitely we're going to post another micro session with all the questions that you put here. Now I have another question that caught a lot of attention. It is from Thomas Hermans. It seems that the fault is quite close to the boundary of the model. How does the boundary condition influence the results?
Yeah. Hello, Thomas. Thank you for your question. I may have an idea on how to answer this question. Let me clearly explain, I'm not a modeler myself. And indeed, it's the work of our PhD student, but I'll do my best. I think what Alberto did, he did forward particle tracking and backward, right? And in the backward particle tracking exercise, apparently some particles ended up across the catchment boundary. Is that what you're pointing at?
So I think, yeah, you can also reply on the Q&A. You can reply to your own question, Thomas, if Koen already answered to your question. I think Alain Dasarge is very active putting questions, so I have to address one of his comments. Maybe because Chris and then Koen, you're more familiar with this. So Alain says, it reminded me a discussion I had with Noel 25 years ago about the expected role of the different faults in the raw area in order to discuss better of the regional groundwater model in relation with the radioactive waste disposal in boom clay. Good that you address this issue now seriously. I think this is kind of an inside story that you have here with the raw fault area. So, but I think what Alain actually is trying to mention here, it is that with this new updating models and so on, bring actually all the issues that are really important in the policy, and then for a larger stakeholder interest, not only to the scientific one. So could you comment on this, Koen, or maybe Chris as well?
Yeah, well, yeah, this is something that hasn't been looked at in detail, indeed, for decades. So yeah, it was the logical next step. And then this GeoEra project, by the way, which is a demonstration project, which I also want to point at, because one of the questions were hinting at where is the innovative part. Well, I can comment on that later on, but of course, in first instance, these are demonstration projects, the GeoEra projects, where geological surveys, but I'm probably picking Chris floors now, geological surveys are trying to show that they actually can work together. Many participants may laugh now, but it's not. It's reality. So that's the main objective. But indeed, in the PhD of Alberto, there is an innovative part, of course, because later on, as I indicated in the slides, a lot more state variables will be added on into the model, and then in the end, he will try to do a joint inversion to use all these state variables to constrain the flow and transport even better.
I think Alberto has to invite all of us to his PhD defense. There will be a full room of people eager to put questions. We have also, I think, questions that moves a little bit from the technical details to the more outputs area. We have Jayesh Desai. Are you analyzing groundwater quality in the region? If yes, is it showing any interesting results?
Sorry, I missed that one.
Okay, so are you also analyzing groundwater quality? So basically, it's not only about looking at the boundaries, but also thinking about the groundwater quality.
Yeah. So Alberto started off with a sampling campaign. So he took samples for tritium, helium-4, radiocarbon, and so in all these data will be used as supplementary state variables to constrain the models. He's also using a huge data set on just like normal or geochemistry, water quality, geochemistry from publicly available databases. So yes, that is also part of his work. And in the past, in the this NUM model has been running like for a couple of decades. Of course, we have been looking into groundwater quality issues before, of course, also, yes. So the answer is yes.
Okay, I was bouncing between asking Chris a question about the harmonization effort between the Voghera and which we all know that has to happen. But I have to put also a question that got a lot of attention because it has 4 votes. It's again for Koen and maybe for Alberto. What techniques were used to model or analyze the groundwater flows?
Well, it's just it's not really a technique, or it's just we use the NUM model and all the groundwater had observations so far and they were used to calibrate the model. And again, I'm repeating myself, but later on other state variables will be used, such as the helium, tritium, radiocarbon, to further constrain the flow and transport models in this area.
Yeah. So I guess it has been very technical, I have to say. Although I'm a geophysicist, it takes a little bit of time for me to understand all the details. But I think, Koen, you did a really great job trying to defend a really interesting work done by Alberto, actually. And I think, Renata, you indicated that you want to start with the poll right now. It is 10:40. It's time to poll everywhere.
Yes, but you can have one last question that was going to go to Chris
Okay,
about
yeah,
the harmonization, because I think that's interesting as well.
yeah.
So if I understood you, it's about seeing how Voghera and or the data from Voghera harmonizes into our project.
Yeah.
I tried to show that a little bit. I wanted to use that also as an excuse to come back to the one that Koen already highlighted. It's about what is now innovative or new about this, because it all seems so logical. And actually that's what we try to do, make it all seem very simple. And yes, it is true what Koen says. We're really at the beginning. We're taking just one case study here, which but at the same time, that case study, it's not just presenting that small part of the country. It's really combining things from different projects, and in the same way we can as easily start combining this with information from other projects. And that is what we didn't do, is here make a technical presentation about how this actually works. We just presented you with the visual output of that visual. And we have a very technical, or part of the audience certainly very technical. The idea is actually that we should discuss the subsurface with, like Renata said, other people, like the different stakeholders. And it's not very easy always to talk about the more technical issues with them, but we think we found an approach where we can actually zoom into very technical details and then very quickly zoom out again and start talking about the implications of that. And that sense we try to give a little bit in this presentation, rather than showing breakthrough results here. And that is, and I hope, yeah, the way you do this is actually you define, like I said, the limits. We show, you focus visually very much on the units, the colored areas in between, but it are the limits, the important faults, for example, or the unconformities. These are what can tie different models together, like we've shown here, a structural model tied together to a groundwater model without much difficulties.
All right, thank you, Chris and Koen, for answering the questions. And as Andrei said, we have all these questions recorded, and we will do our best to address them over the next few weeks. Give us a bit of time, but you will hear back from us. We apologize that we cannot answer everything, because we want to try to stick to 1 hour and a half that we promised. So now we're going to move on to our last session, which is the interactive session, because you've been listening a lot, but we want to hear your feedback about what you've seen for sure. So for who missed it at the beginning, we're using Poll Everywhere. So you go to pollev.com/GeoEra900. The link is in the comments, in the chat as well. You register with your name, and you get ready to answer our questions. So we're gonna start off going back a bit with Chris' presentation that he showed a little bit on how the structural framework is built. So the statement is, the way GeoConnect³ presents geological information is easy to understand. And you have several options there. So we'll see how it goes. I see results coming in. Some disagree. For the ones that disagree, and for the ones that agree as well, it would be nice if you can send us some comments through our email, geoconnected@geoera.eu, because obviously this is a work in progress, and the idea is to have your feedback to try to try to give the best direction possible in the year remaining of the project. But I see that a lot of people agree, so that's nice for us. It's a nice distribution there. So we have around 20 results. So I'm going to move forward to the next question. So it's another statement. You can agree or disagree. If a subsurface activity threatens groundwater resource, this activity should not be allowed. And for this one, I would like to ask Chris maybe for a comment, because it was something he touched upon in his presentation by talking a bit about the complexity of the interaction. So Chris?
Yeah, this is one that we really trod in the audience. So I touched upon it, but I didn't answer it. And that's because I do not think there's a simple answer to this. But we just want to see if how many people would actually be willing to take up that this or would actually think it would be a point that should be discussed. And I therefore very much like the different bars that I see go up, with the strongly agreeing still. So basically, groundwater is should never be given up in or never be risked for another activity, being in the lead now. That learns us a lot also to prepare for next sessions.
Good. Okay, a few answers still coming in, but I think we can now move on to the next question. So what are the pros and cons of the GeoConnected way of presenting information? And this is referring back to Chris' presentation again. And please indicate if your answer is a pro or a con. And maybe now, Koen, I know you've answered a lot today already, but would you like to make a quick comment? Because I think a lot of this about GeoConnected you're seeing for the first time, or you haven't seen much about it, but what did you think about the embedding of the different models, for example, in the structural framework?
Yeah, I think that this at least for the part of the visualization, it's this is enormous enormous step forward. I think scale is always a problem in earth science, and embedding these different scales in one single viewer, for instance, that makes that could make a real difference, I think. Yeah.
Nice. Yeah, I see an interesting con there. That is something that we discuss a lot. How can we deal with uncertainty? And yeah, this is a very good point that maybe Chris can make a quick comment about it, because
I'd love to. Yes.
Yeah.
This is actually, I mean, uncertainty is what drives me when I have to get up in the morning. And actually we didn't show it, and this actually reminds me that we should do something with that in one of the next sessions, although it's not very easy to come up with a good case study. But the whole idea with that we have behind the structural framework is that you can, well, there are different levels at which you can trap uncertainty. So I'm going to go to one of those aspects only. For example, say that you have a very fundamental one where you say, oh, Rao fault, well, it's either permeable or not permeable, or it is there or it is not there. This means that you can actually link different interpretations to your structural framework and come to different visualizations of your subsurface based on turning these hypotheses on and off. So we do not only show information, we actually show interpretation, and that is very much embedded in the system as well. But we should show it in one of our sessions, or at least at some point in the future.
Yeah, and just to complement that, if this is more a comment on more specific uncertainty, as for example in traces of faults and things like that, that we're dealing with visualization of uncertainty in collaboration with other GeoEra projects as well, but basically with the buffer around traces, so that because this data will be downloadable. So it's like if you see a trace, a very specific one, but there's always an error margin there. But yeah, I see that one very good point is that not all stakeholders have a scientific background, so vulgarize as much as possible, and this we agree 100% with that. That is one of the things that GeoConnect³ is taking very seriously. Obviously, that for today it was pretty much a very technically oriented webinar, as we were expecting. But within GeoConnect³ and for all of the GeoEra projects, there's something that's called the project vocabulary, where all of the information that we presented is defined and referenced and everything. And for GeoConnect³, we're doing 2 versions of this project vocabulary. One with, let's say, jargon-free, or as far as we can. But really, like if we're talking about a fault, we will have a definition of what is a fault, for example, which seems like very basic, but we think that it's good to like centralize all this information in the same place in the GeoEra platform, and this will be it will be a nice tool altogether, let's say, not only for stakeholders as well, but maybe as teaching tool and everything. So I like that this is popping up because it's something that we address as well. So thank you very much for your answers. I see we stopped a bit, so I move forward to the next one. So this is a bit more general. How can we make hydrogeology more understandable to everyone? And kind of links to my previous comment as well. Because at least to me, I'm not a hydrogeologist. A lot of the technical information, it's really hard to grasp, even if you have a geology background. So we would like to maybe gather a few ideas from you, if you have been thinking about that. And maybe I will ask Koen if you have, if you ever discuss this within Voghera, for example, and if you have a few ideas that you can talk or you can tell us. Oh, you're muted, Koen. Sorry. I saw you. Yeah. Good.
First answer is is a good one. Teach it in high school. Well,
yes.
Yeah. Oh, yeah, that's a difficult. Yeah, that's more understandable to everyone. What needs to be on? Yeah, that's a difficult question. You have to make, yeah, you have to move away from the technical part in one way, I guess, and yeah, make it understandable to in such a way that stakeholders can understand it. And of course, there, with making it understandable to everyone, that's exactly the problem, I think, because with everyone, it's then you're always dealing with so many different backgrounds. So even though, I mean, some are not hydrologists, but even though I have a geological background or a scientific background, other or managers without perhaps a scientific background. So that's, yeah, that's at least one of the considerations that need to be taken into account, I think. Well, it's difficult to make it understandable to everyone to every single person in a mixed audience.
Yeah, true.
I think I can see here, Renata, very nice answer. I found it myself, convert science questions into societal questions so they can be resolved by the policymakers. I think that's a really nice suggestion. And this holds
and I
the
think
key.
that goes for science in general, right?
Yeah,
So yeah, that's very nice. And I also see make it highly visual, which is very true, because if you can visualize something by making use of, we have so many modern tools that we can make use of for these purposes. And Chris, would you like to make a quick comment?
Yeah, because I think the people questioning the question actually have a point here. Do we need to make it understandable to everyone? I mean, as a project is of course a very nice ambition, but actually the one that you said, yeah, you need to get it through to policymakers by translating the societal questions. That means that you're not making it understandable for everyone, but only for the people where it actually matters, that will determine society. Or indeed, yeah, if you want to make it interesting for everybody, understandable, then you have to go to the fairies and the trolls. Yeah. So I mean, it's a challenging question, but I think that's a very important aspect. Everyone sounds nice, but should that really be your goal?
Yeah, that's a good point. Okay, so we move further on, and these will be the last two questions. So this is a bit on the positive side, but what did you like most about this session? We're obviously, we have a few webinars coming up still, and we will have the events from the Pannonian Basin that will likely be online as well. So we really want to learn what are the things people like the most, so we can keep on doing them. And if no one says anything, it will make us a bit sad, but that's okay. Okay, we have one answer. That's good. But yeah, it's very challenging. I mean, obviously, this event was meant to be a live event that we can actually interact and it's sort of a workshop, like, which is not possible at the moment. So we had to see what would be the best format. We know everyone is overloaded with online events lately, so it's we know it's a bit tricky, but it's really nice to hear from you. A few comments there. So thank you very much for your answers.
I think also we initiated in the science world a roasting of a scientist. You have it in comedy, but we experienced here with Koen.
Okay, so I think we can, yeah, we have some nice comments there. Thank you very much. So we move on to the last one. How would you rate this event? You can be honest with us. We can take it. But yeah, we're really reaching the end of the event here. But it's very nice to see that you stayed with us. And obviously, we apologize for a bit of a delay at the beginning. For us, it's very nice to organize these. And it's good to see that most people that are voting say it was good. So that's nice. That's reassuring. Okay, so that's it for today. I don't want to keep you over our time, but just remind you that we still have two webinars coming up. Tomorrow, we have a webinar on geothermal energy. And most importantly, on Friday, we have a sort of a recap where we want to address all of these topics and others on subsurface uses in this subsurface interactions session. So I really encourage you to register and come back to see us on Friday. The link should be there in the chat for you. And as well, if you want to keep posted on how we're doing with the project, we are all over social media. And as I mentioned before, on the GeoEra website, you really have the pages of each project. So there you can find our information and our project blog as well. But we're on Twitter, Facebook, LinkedIn, ResearchGate, and on YouTube. This session of today was recorded and will be available on YouTube. And all of the links are there in the chat for you.
maybe also specifying if the slides they're going to be available after the session.
Yes, sorry, I forgot about that. So we're compiling the slides of all of the webinars, and we will make them available in our project website. So when you get the post webinar information, we will redirect you to get them. So that's it from our side. Thank you very much for everyone that joined us today. I really hope that you enjoyed it and that you could get some nice information out of it. I encourage you to send any comments to our email, geoconnected@geoera.eu. And I would also like to thank once again our guest speaker, Koen, for a very nice talk. And thank you, Chris, for representing our project. Thank you, Andre, for the moderation. And hope everyone has a nice day, and see you tomorrow or Friday.
Okay. Thank you.
Bye-bye.
Bye to everyone.
Thanks, everyone.
Bye.
Bye.